Hi, this is Rick. Let's start where we left off, and we're now in part 2, and don't forget to follow along with your books because this presentation is not going to replace your book for details and all those page numbers. All right, as we look at the different topics that we covered in part 1, we actually went through the repetition structure. So we have 3 structures so far. We've got sequence, we've got select, and now we have repetition. When we look at this repetition, we looked at 3 different kinds of loops. We looked at the while do, which tests and then runs. Then we did the do while, which runs and then tests. It's the test at the bottom. And then we have the do until, which we don't use very much. In this time, we're going to go ahead and look at the count-controlled loops. Now, what I skipped over there was that 5.2 was a condition-controlled loop. And we said, if this condition is met, then do the loop. Now we're going to say, let's just use a count. So we're going to talk about count-controlled loops and the for statement, which is a very special count-controlled loop. We'll talk about calculating a running total, which is what loops are good at, sentinel values, and we'll take a look at nested loops, which are loops inside of one another. So here we go. We did see this slide last time, so if you can name all 5 parts, we'll go on. Did you get it? Let's go on. When we talk about loops, we said there were 2 kinds. There was the while do and the do while. The while do tests and then runs. It's called a pre-test loop, and it runs until the condition is no longer true. The do while loop actually runs and then tests before running again, so it's called a post-test. And it runs at least once and then runs until the condition is no longer true. Let's do a desk check. You ready? Remember this? We're going to fill one of those in. So here's our issue. Let's go ahead and solve this particular loop. We'll fill in our iterations at the top. So D is equal to 4, E is equal to 6, and F is equal to 7. Did you get it? Should be fairly simple because D is never greater than F. Oh my gosh, it doesn't run at all. Correct. Now that we've sharpened our brains up a little bit, let's go ahead and look at our chapter material. There are 2 classifications of loop, definite and indefinite. In fact, we have definite and indefinite on all 3 types. So our while do has a definite type of loop, which means it runs a predetermined number of times. Then it's got the infinite, which has to be stopped externally from running, and we usually do that with either a keyboard entry or an end of file kind of thing, saying just keep running until you run out of records. The do while also has those 2 different things. It's got the definite, which runs a predetermined number of times, and it's got the indefinite, which must be stopped externally, which is usually a keyboard or end of file. So you see how they're the same. We've got while do's and do whiles, both with definite and indefinite times they run. So let's just kind of take a look at it. If we take a look at a definite loop, it says it executes a predetermined number of times. An indefinite loop says it executes until we're out of records, or it's manually stopped, like continue YN. Okay, so that would be an external stop. So now we're looking at count-controlled loops. Some general concerns about the loops. First of all, don't forget to initialize the loop. Remember that, the initialization where we said count equals 0? That's important. Don't forget to increment. That's the counter. Or decrement. That's still the counter, but it's going in the negative direction. Many loops are interchangeable, but generally we can say use a while loop if there's an opportunity for it not to run at all. Cool. That way we get out of that entire processing system. Use the do while if we have to process it at least once. And use a for a specific number of iterations. Now, we haven't introduced a for yet, but we will soon. So let's talk about a definite while do loop. In other words, a pre-test loop. So let's talk about a definite one. It's the most common kind of loop out there. And we have what is called a for loop. In other words, we're going to take and say a while do loop, the pre-test loop, that's definite. We know how many times it's going to run. We can set up as a different kind of structure called a for loop. So it can, what it's going to do is going to do three things at one time, and it's really, really cool. So it's going to increment, it's going to initialize, and it's going to control the number of interactions. So how does that happen? So the count-controlled loop, also known as the definite loop. So the count-controlled loop, the definite while-do loop, iterates a specific number of times. When that happens, we actually create a for loop, and this is what a for loop looks like. So for counter variable, there's that number, equal to starting value to maximum value. Then we've got a couple statements to run, and then we end the for. So there's our specifics. For a counter variable equal to a starting value, running until the maximum value. So it's going to run over a range of numbers. So we might say for x equal to 1 to 7. Okay? So it's going to run that many times. The initialization process, or the test of the increment, is expressed in the control of that loop. So here we go. You ready? This is using a for loop. So a for statement, or a for loop, is a definite while-do loop. It provides three actions in one structure. It initializes, it evaluates, and it increments all at the same time. Woohoo! And you can see that in just a minute. It takes the form of something that looks like this. For the control loop variable, equal to initial value to final value, step value. So in other words, if we said step value 1, it'd go 1, 2, 3, 4, 5. If we said step value 5, it'd go 5, 10, 15, 20. If we said step value 10, it would go 10, 20, 30, 40 until we reach the limit. Okay? Then we're going to do something and end the for. So this is only for definite loops. All right? Which means we know the number of times it's going to run. So using a for loop, here's an example. So for count equal to 0 to 3, step 1. So how many is that going to do? Well, it's actually going to do 0, 1, 2, 3. Good, okay. And then we're going to say hello. So now, then we're going to end it. Okay, so we initialize the count to 0. It checks count against the limit of 3. If the evaluation is true for the statement, then it prints the label. In this case, it would output hello. All right? And then it increases the count by 1. It gets kind of complicated. Let's take it as a diagram. All right? So here's a diagram. Here's our special little wonderful detail loop. And go ahead and trace down the logic of that thing. See if you can locate all 5 parts. So if it's only for definite loops, we know how many times it's going to run. In this particular case, it's going to run from 0 to less than 100. All right? So here we go. We're going to say that the label counter is going to be a variable called I. And by convention, we just call it I. And I think it means for incrementer or something like that. But it means anything used to control this loop is going to be called I, just by convention. So let's kind of write it. We're going to write it in C++ down here in this box. So we're going to say a for statement would look like this. It's going to take I, and it's going to initialize it to 0. The condition is going to be I less than 100. And it increments in I plus plus, or I plus 1 each time. So it's going to say I equals I plus 1, or you can shorten it to I plus plus. Then, if you're going to put it in a for statement, this is what it's going to look like in C++ code. So here we go. For I equals 0. See where that comes from? Semicolon. I less than 100. Semicolon. I plus plus. So it's incrementing. And then here's the loop body down here. So notice that our loop counter is here. There's our condition, and there's our incrementer, or our decrementer, or our counter. All right? So we've accounted for all the parts. So there's our body, and we do want you to notice one other thing. There is absolutely no semicolon at the end. I know that's frightening, but it's one of those things you have to be aware of. So as we do it in SFC, this is what it's going to look like. And go ahead and look at our initialized variable. There's I, and our condition, and there's our counter. And all it's going to do in this particular case is display something. So what is it going to display? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See how that works? Okay, now it's your turn to try something. Ready? We're going to have a while do loop that displays the numbers from 0 to 10. It's fairly simple. We just did that. Go ahead and stop the video and figure it out. Here's the next one. A while do loop that displays the numbers from 10 to 0. Ooh, how would that work? Stop the video, work it out. A while do loop that displays the count from 0 to 100 by tens. So it goes 0, 10, 20, 30, up to and including 100. Stop the video, figure it out. All right, let's calculate a running total because loops are very good at this. This is the way all of the totals that you get at the grocery store are actually rung up. A running total is the sum of the numbers that accumulates within each iteration of the loop. So what we're going to do is continue to go around. So we're going to say that we can buy 5 items from this particular vendor. And so we've got the counter set to 0. There's our condition. And as long as it's true, you'll notice that we are actually going to say down here, they're going to input the number. Then we're going to say set total equal total plus number. What did that just do? Well, we said take the total variable and add what we just entered to it and then stuff it back in the total variable parking spot. Then add 1 to the counter and go around again. Within each loop, you can have another loop. So you can have a nested system of loops just like we had a nested system of ifs. Here we are with the loop saying, okay, we're going to set the hours to 0, and then we're going to have our first condition is hours less than or equal to 23. And if that's true, then we're going to set the minutes equal to 0, and our condition would be minutes less than or equal to 59. So what is this? Well, this is a counter, isn't it? Trace this logic through. It's on page 222, and make sure you understand it. Ready for a desk check? Okay. Remember our chart? Aha! This is what you're going to need to do. But notice at the other end, I've put down this little thing that says print. Yeah, we're going to count the number of times that the label prints. So here we go. How many times does hello print? Stop the video, figure it out. Here's another one. How many times does hello print? Stop the video, figure it out. By the way, I'm not trying to frustrate you by not giving you the right answers, but I want you to work them out and then check with somebody else or bring them to class and we'll do them together. But do work them out. In other words, put your effort into it. By the way, one other thing you need to do is turn to page 225 and do review questions 6 through 10. Stop the video, do those things, and when you come back, you'll find out we're already done.